In section 4.2, we will multiply and divide radical expressions. The goals of the lesson are to multiply radicals, divide radicals, and to rationalize monomial denominators. In each of the following problems, we will go ahead and multiply these radicals together. One thing we want to pay attention to is that if they're going to stay in radical form, we need to make sure that the index is going to match for each of these. When the index matches, what we'll do is we'll multiply the number in front of each radical by the number in front of the other radical. So for in example 1, we'll be multiplying the 2 by the number in front of the square root of 2, which is a 1. And then we also multiply the inside number with the inside number. One thing we want to look at is simplifying each radical. Sometimes it's going to be best to simplify them right away. Other times we might want to wait and simplify it at the end. And like I talked about, we'll be multiplying corresponding numbers, outside with outside, inside with inside. So in example 1, again, if I look at simplifying these, neither of these are going to simplify initially. So what we'll do here then is multiply the outside number here by the outside number here. So 2 times 1, which gives us 2. From there, I'll do 3 times 2, which gives me 6. If I could simplify that further, I would, but this is going to be the final answer. In number 2, here it might make sense to simplify them first. So the square root of 9 is going to give me 3. So I'm really looking at 3 times 3 here, which is going to give me 9. The other thing I could have done is I could have done 9 times 9, giving me the square root of 81, and the square root of 81 would still have given me 9. So either way, that's going to be the correct answer. In number 3, again, I could simplify these initially, or I might consider just multiplying 5 times 20 right away and then simplifying it from there. I chose to use that method because 5 times 20 is 100, and then once I have the square root of 100, that's just going to turn into 10. But again, even if you had changed this right here into 2 root 5 and then multiplied them, you then would have gotten 2 root 25, which would still turn into 10. For number 4, I can't simplify them initially. When I go to multiply them, I'm going to get the square root of 12. Since it's a square root, I'll be looking for pairs of the same thing. So as I break down that 12, there's several different options, but when it's fully broken down, you should end up with 2 2s and a 3. So I'll be able to take out a 2 and have a 3 left over on the inside, and that would be my final answer. Now we need to start paying attention to the index here. In number 5, we're looking at a cubed root, same thing with 6 and 7. So no longer would we be looking for pairs of the same number, we're looking for 3 of the same number. Now again, in 5, I could choose to simplify the second one first, or I could multiply them right away and then break it down from there. I chose to go ahead and just multiply the outside with the outside, so negative 1 times 1 giving me a negative 1, or just a negative out in front. Then since they're both the cubed root, I can go ahead and do 2 times 8, giving me 16. From here, I want to break down 16, and there's several ways to do that. I'm choosing 2 and 8. The 8 breaks down to 2 and 4. The 4 breaks down to 2 and 2. So no matter how you broke it down, we should end up with 4 2s at the end here. I'm looking for a set of 3 of the same. I do have that. That's going to come outside. So we go ahead and multiply the negative 1 that we already have out in front with the 2 that's going to come out, and that's going to give us negative 2. I have to make sure I'm writing this as the cubed root here. And then the only thing left over at this point is just this 2. So we're going to end up getting negative 2 times the cubed root of 2. For 16, same thing. You could break it down right away if you would like, or we can go ahead and multiply it right away, which is what I did here. We talked about this a little bit with section 4.1. If we're dealing with an odd index here, we are allowed to have a negative underneath. And what happens is I can just automatically take that negative out. Then when I go to break down 64, I'm ignoring that negative. And as I break it down, I chose to start with 2 and 32. From 32, breaking that down further, I got 2 and 16. I kept going. I get 2 and 8, 2 and 4, and 2 and 2. So now when I'm looking for sets of 3 of the same number, I've got a set of 3 2s there and another set of 3 2s there. As both of those come out, I do 2 times 2, which is going to give me 4. But then I already have a negative out in front that we've addressed, so that is going to give me a negative 4. For 7, again, I could try to break them down initially, or maybe I just multiply. In this case, I got the cubed root of 128. As I break this one down, There's several different ways you could have broken this down. I chose to break it down this way. That way I have 3 4s right here, so I'll be able to take out a 4. Now you may have broken it down and ended up with a total of 7 2s. If that was the case, you would have had 2 full sets, and as you multiply that, you would still get a 4 coming out. And then this 2 right here, either way, is going to be left over. So we get 4 times the cubed root of 2. Again, really make sure that you're always remembering that index here. And then finally for number 8, when I multiply this one, again, outside with outside, so negative 2 times 1, which is negative 2, 5 times 10, which is 50. If I can break that down further, I need to. So I'm going to go ahead and break that down. And I end up being able to take out a 5. So then I do 5 times negative 2, giving me negative 10 on the outside, and then that 2 is going to stay on the inside, and that ends up being my final answer. We're still going to be multiplying in this set of problems. It's just that now we're looking at multiplying a single term by a set of 2 terms. So as I multiply this root 3 in, I do need to distribute that in. Root 3 times 1 is going to give me root 3. Root 3 times 2 is going to give me root 6. Now, before I box this in and say that this is the answer, I want to look to see if either of them can simplify further. And in this case, they can't. So that's going to be my final answer. They also can't combine because they're not considered like terms. We have a root 3 here, and since this is something that's not a root 3 and can't turn into a root 3, that's why we cannot combine these. For number 10, as I distribute this root 5 in, I end up getting the square root of 15 minus, and then again, remember, this is an outside number 1 times this outside number of negative 4. 1 times negative 4 is negative 4. Root 5 had nothing to multiply with over here, so we just leave that as root 5. If I could break them down, I would. If I could combine them, I would. But neither of those are going to be options in this case. For number 11, as I multiply this in, I end up getting 3 root 16 minus 12 root 10. Now I can take the square root of 16. The square root of 16 is going to be 4. So I really have 3 times 4 here, which is going to turn this into 12. Or you could have broken this down other ways, and you may have ended up getting a set, 2 sets of 2, which when they come out turns into a 4. We then multiply by the 3, and that's going to give us 12. This one does not simplify, so this is just going to be 12 minus 12 root 10. Again, I cannot combine these. Now for 12, in this case, I've got a binomial, 2 terms, times another binomial, 2 terms. And so with this, we need to multiply the first, the outside, the inner, and the last. Now, some of you might choose to set this up using the area model, which is when we set up boxes. Others are going to choose the double distribute method. Whichever way you do that is fine. What we should end up getting here, and I use the double distribute method, I did 4 times 2 and got 8. Then I do 4 times negative 5 root 3, giving me negative 20 root 3. Then root 3 times 2, which is 2 root 3. And then finally root 3 times negative 5 root 3. Well, with that, I've got a 1 times a negative 5, which is negative 5. Root 3 times root 3 is going to be the square root of 9. Now, before I box this in and say it's the answer, I have to look for anything that would simplify. So the 8's not going to simplify. These two will combine. So we're going to want to put those together to give me negative 18 root 3. And then finally this one over here, the square root of 9 is 3. So this is negative 5 times 3, which is negative 15. And then finally, as I combine 8 and negative 15, that's going to combine to give me negative 7, negative 20 root 3, and 2 root 3 combine to give me negative 18 root 3, so that ends up being our answer. In 13, I'll do the same thing. I'm going to double distribute, and as I do that, I get this, because root 2 times 1 is root 2. Root 2 times 3 root 7 is going to be 3 root 14. Negative root 7 times 1 is negative root 7, and negative root 7 times 3 root 7 is going to be negative 3 root 49. Now there's a little more cleaning up I can do here. The square root of 49 is going to turn into 7. So I have negative 3 times 7 here, which is negative 21. So at this point, I want to look to see if I can combine anything. Nothing here has the same radicand, so we're going to go ahead and say that that is the final answer. And then finally for 14, again, I'm going to double distribute. So here, 3 times 3 is 9. 3 times root 5 is 3 root 5. Negative root 5 times 3 is negative 3 root 5. And then negative root 5 times root 5 is negative root 25. Again, the square root of 25, that part's going to simplify. Also, these two are going to combine, and they're going to actually cancel each other. So we're really left with, It's going to end up being a 9 minus 5, and that final answer will be 4. And we want to think about why that just happened, why we just got one single number here. We didn't have any radicals involved in our answer. And this is a very important concept for what we're going to do in the next lesson. And what we want to notice here is that these are examples of conjugates. What they are is the exact same binomial expression in both cases. The only difference is that the sign in between, we have one of each. One is a negative and one is a positive. And that leads us to our next part. We're going to find the product, which means we're going to multiply of the given value, so like in 15, 3 plus root 2, and its conjugate. To come up with its conjugate, we leave the 3 plus root 2, and all we're going to do is change that plus to a minus. So its conjugate is 3 minus root 2. Now we multiply that out. 3 times 3 is going to give me 9. On the outside, I'm going to get negative 3 root 2. On the inside, I get positive 3 root 2. Anytime we're working with conjugates, those parts should cancel each other, and they do. And then finally, I've got root 2 times negative root 2, which is going to give me negative root 4, and that is going to turn into a negative 2. So I end up getting 9 minus 2 here, which means my answer is going to be 7. So for 16, we'll do the same thing. Instead of root 3 minus 4, it's going to be root 3 plus 4. Now as I go to multiply these out, I can do root 3 times root 3 to give me root 9, which is then going to turn into a 3. I can skip this outer part and this inner part because I already know they're going to cancel. Then I'll do negative 4 times 4, which gives me negative 16. So here I'm looking at 3 minus 16, which when I combine is going to give me negative 13. And then for 17, again, root 5 times root 5, I'm going to get just 5. Root 5 times 2 root 3. I can skip that because I do know that my middle 2 should end up canceling, but in this case I did write it out. Root 5 times 2 root 3 is 2 root 15. Negative 2 root 3 times root 5 is negative 2 root 15. So again, these are going to cancel as expected. Then when I do negative 2 root 3 times 2 root 3, negative 2 times 2 is negative 4. Root 3 times root 3 is going to give me root 9. That square root of 9 is going to change into a 3. So then negative 4 times 3 is negative 12. So here I'm looking at combining 5 with negative 12. And that is going to combine to give me negative 7. And of course, like we talked about before, the 2 root 15 and negative 2 root 15 are going to cancel. And the last thing that we're going to look at today is how to divide with radical expressions. So one thing that we're going to look at is to see if we can simplify or to see if there's any perfect squares. We also want to reduce if we can, and then if we must, we will rationalize the expression. One thing that's really important to note on these is that you're not allowed to have radicals in your denominators. So in 18, again, if I'm looking to simplify any perfect squares here, the square root of 6, that's not going to be perfect, but the square root of 25 is. So root 6 is going to stay root 6, but the square root of 25 turns into 5. Since this cannot simplify any further, and also because we don't have a radical in the denominator, this is our final answer. For number 19, I don't have any perfect squares here right now, but I can reduce. Since these are both inside of the radical, I can do 18 divided by 2, which gives me 9. So I'm looking at the square root of 9 here. Then the square root of 9 turns into 3, and 3 will be our final answer. For number 20, they're both cubed roots. I do want to make sure that that happens. I am allowed to have the cubed root of a negative because this is an odd power. From here, negative 81, the square root of 81 is perfect, but this is not a square root. This is a cubed root. So instead of me trying to break this down yet, I'm going to go ahead and look at the fact that this is inside and this is inside, and they do divide to reduce. So negative 81 divided by 3 is going to give me negative 27. So I'm looking at the cubed root of negative 27. The cubed root of a negative means a negative is going to come out. And then for 27, if I broke that down to 3 and 9, and then the 9 down to 3 and 3, I will be able to take out a 3. So negative 3 is going to be our answer here. On 21, I start this the same way. I'm going to look for perfect squares, and the square root of 4 is going to give me 2. So I am going to get 2 divided by the square root of 3 here, and this would not be there initially. Now from here, this is not, 2 over root 3 is not an acceptable final answer, and that is because I have a radical in the denominator. So what we do when that happens is we rationalize. We think about what we can multiply the denominator by so that we won't have a root in the bottom anymore. And what we'll want to do here is multiply this by root 3, and we'll do that to the top and bottom. Now as I multiply, 2 times root 3 is going to be 2 root 3. Root 3 times root 3 is root 9, which then turns into 3. So 2 root 3 over 3 is the final answer. On 22, again, I don't have anything perfect here. I can't reduce. 5 divided by 2 is not going to reduce. Then from there, I'm going to go ahead and rationalize. So in this case, in order to get rid of the square root of 2, I am going to want to multiply by root 2. What I do to the bottom, I have to also do to the top. Root 5 times 2 is going to give us root 10. Root 2 times root 2 is root 4, which then turns into a 2. Now from here, again, I'm always looking to see if I can simplify this further. I cannot do 10 divided by 2 here because this one is an inside number. This is an outside number. So I will not be able to reduce this. Also, I don't have a radical in the denominator, so this can be an acceptable final answer. Now for 23, you want to be careful. First of all, we don't have anything perfect. Again, if it was the square root of 4, then we would be looking at something that's perfect, but this is the cubed root of 4. So from here, we're trying to get rid of the cubed root here. So I'm going to have to multiply by cubed root of something, top and bottom. Now don't automatically choose a 4 here. We're not automatically choosing the bottom number. What we're looking for is, in this case, it's a set of 3 of the same number. So right now, if I broke down that 4, I have 2 2s. I only need one more 2 in order to give me that full set of 3 2s. So here I'm going to want to multiply top and bottom by the cubed root of 2. Now when I do that, I get the cubed root of 10 divided by, the whole reason that I did this was so that I could take a 2 out. So if you wrote this as the cubed root of 8 and then changed it to 2, that's fine. Or we can just say I was going to have a full set of 3 2s. That means that that can come out. Once again, I cannot divide these because this is an inner number and this is an outside number. Now the assignment that corresponds with this section is going to be in Delta Math. There's 3 different assignments that you're going to look at today.